Go for the screen sharing.
Great. This session is versioning with FHIR Packages with Ward Weistra and Ardon Toonstra of FHIR and moderated by Marco Visser. Ward.
Thanks so much, Lynn. So thank you everyone for joining. I see we have a great number of people on the line. Thank you so much. I hope you're having a great time. My name is Ward Weistra. I'm the product owner for Simplifier and Forge at FHIR. You know FHIR, of course, as being one of the co-organizers of this event, of DevDays for years. But FHIR is a company involved in FHIR since the beginning, and we provide all the software, tools, and training that you need to bring FHIR to life. And I'm really someone from the product side, as I mentioned, and Ardon Toonstra is on the line as a co-host, and he will be moderating the session together with my colleague Marco. And Ardon will be introducing some homework assignments that we have after this. It's not really a Let's Build session, but we do have some assignments to get you going on your own time around with packages. So the talk today is about versioning with FHIR Packages. And I'll start with a kind of outline of what we're going to do. First, I'll explain to you what problem we are solving with FHIR Packages. There's other versioning methods. Why do we need packages? Then, once we've established that, we're going to the next question, and that is, what are packages? I'll introduce what packages are, how they're built up, which parts they contain of. And then, of course, the real questions get to your use cases. How can you use packages? So we'll start by building on top of them existing packages. Where can I find the right package for me? How do I install it on my machine or on a server that I'm working with, a FHIR server? And how can I build my own profiles on top of them? Then in the last section, we'll go to, okay, now you've seen what you can do with packages. How can I make my own? How can I distribute for my customers FHIR packages? So we'll cover how you can build FHIR packages and how you can distribute them in the FHIR package server. And finally, as I mentioned, Ardon will introduce you to your homework assignments. So let's start with what are we trying to solve here? And I'll take a few steps back there to how in FHIR we refer to things, how we identify things. And for a part of the FHIR resource that is FHIR resources that is very clear, and that those are FHIR instances. I have a patient instance, for example. If I know the server that it's on, the type of the resource, which is a patient, I know the ID, and I know the version that I'm looking at, I know exactly which resource we're talking about. And you can build this up as a FHIR URL and get exactly that, that FHIR resource. And that works because FHIR instances are unique to your server. When it's transferred, the ID might very well change. So those are only guaranteed to be unique on the server. That's different, of course, for FHIR conformance resources. So any FHIR profiles and FHIR value sets and code systems, etc. Anything you need to define your FHIR data model or your API model. So what we're using there, of course, are canonicals. They are meant to be shared over multiple servers, for example, on a national level or on specific use cases. And these canonicals need to be the same so that we can exchange with each other and specify that we're talking about the same thing. So when I have a patient instance for my organization, then I can claim exactly, okay, I'm conforming to this profile with this canonical and I can be tested against that. And similarly, the profile, when I share it with claim its own URL. So this is just a unique identifier for canonicals, which is meant to be unique globally, unique outside your server at least, shared outside your server. So let's put that in an example here. I have a patient profile, and this patient profile defines its own unique canonical. So my organization / structure definition / patient. It can be a URL that I can actually put in the browser, but it doesn't necessarily need to be. Then when I start building other profiles and I refer, for example, from my observation profile to that patient profile. So this is an observation, has its own canonical, but it's referring to another profile, the patient profile. It can use the canonical, and then we know exactly what it points to. Similarly, if I have a patient instance, I claim this conformance to this patient canonical, and we know exactly to what I'm claiming conformance to. And this sounds all well and good, but there's of course an issue, and that's the fact that actually canonicals turned out not to be so unique globally. For example, even when we look within the FHIR spec, if you look at the DSTU1 patient or the DSTU2 patient, etc., the patient canonical has just stayed the same all the time. So when I'm claiming conformance to a specific canonical, that's not enough. I don't know exactly which profile we're talking about here. So we need to go one step further and not just specify canonicals, but also the version of a profile. And that's what was introduced later to make sure that we can handle these multiple different versions of the same canonical. So let's put that in an example. This patient profile specifies its own canonical, but also specifies its version. And then when we're referring to that patient, patient profile, we specify the canonical and then the pipe and then the version, and similarly for a patient instance. So that's already a step better. But then this does give some unexpected problems. We start versioning the different individual resources. But if I want to, for example, have the coherent set of all national profiles for a certain country, then I need to hunt down together all the right profiles that fit together. So I might have a patient profile of version 4.2, but an observation profile which should go with that of a version 4.3 or something. So this is tricky. I need to make sure that I have exactly the right set, and it's not clear from these versions. And secondly, once I start, for example, updating the patient profile here, I made some changes to this, and we were releasing a new version of the patient profile. I update the version number 4.3. I also need to update everything that points to it. So the observation profile, any patient instance, nothing has changed on these instances themselves, but they do need to be updated. So you have this cascading effect of updating your versions. So there's a problem with versioning the individual resources. And that's why with FHIR packages, we're going to versioning the group and not the individual items. So when I'm looking here at the same example, I put my patient profile and my observation profile together in one package. It's kind of a zip file, so it comes together, and you always know which patient profile goes with which observation because they're together in that same thing. That package has a name, it has a version number, and as long as I evaluate my patient instances within the right scope, so I have a FHIR server set up with these packages loaded, and I'm testing my patient instance against it, it will be evaluated against everything within this package. So that's the basic idea behind FHIR packages. And I should mention at this point, you can still version the items, but that's maybe something to come back to. That's not necessarily needed in every use case. At least you don't need to use it in these references to each other. So that's the first part. What problem are we solving? I hope I've convinced you that packages are super useful for this. Then let's go into the specification. What exactly are packages? Well, I've made this beautiful animation here of a FHIR package. And this FHIR package is just a file that I downloaded from the internet. I found it somewhere, and we'll discuss later where exactly you can find them. But it will have a name, dash version number. This is kind of a good habit to do this, but it's not necessarily necessary. But it will always be this tgcz file. So this is a tarball, not too unlike a regular zip file. You can just download 7-zip and open it, and you can see what's in it. So let's unpack this package. So what we see in there is that there's only one thing in there basically, and that's the package folder. So this is really necessary from the spec because we're building on NPM. And in this package folder, this is the only folder you'll see when you open it first, but there will be multiple things in there. First of all, there will be a file in there which is kind of the metadata about this package, and that's called the package manifest, and the file name will be package.json. This is a JSON file describing everything that's in the file, stuff about it, and we'll go deeper in that in a moment. So this is actually the only necessary thing to create a valid package. But generally, you will also have in this package all your conformance resources, of course, because that's what we were trying to version. So there'll be one in there, there will be multiple in there. Those will be your profiles, your code system, your implementation guides, etc. And we have specified that they always need to be in the JSON format. You can still keep your source data in XML, that doesn't matter. But when you open a package, it will always be a JSON representations of those profiles. So this is generally what you will find in there. But then this is also the only thing that basically can be in that package folder directly. But you're also allowed to put other folders within that package folder. And a common example of that is the examples folder. If there are examples in your package, you should put them in this examples folder. And again, they need to be in JSON representation. So there will be one folder lower than the package in the examples folder. And then there can be multiple other folders in there. So for example, if you're an XML aficionado, you can still put the XML in there. You still need to have it in JSON, but you can also put the XML in an XML folder. And then there's a /other folders or /RDF. You can put more in there. Don't necessarily make it a big thing. And don't expect other tools to work with it, but technically you can. So this is what a package looks like. The more formal specification of this lives on the Confluence, and it's managed by the FHIR. So it's not a standard yet that is in the spec that is being balloted, but it is under management by the FHIR to make sure that it doesn't change rapidly. It's based on the NPM packages. So if you're familiar with JavaScript, you're familiar with NPM. And we've based it on this, and we try to stay conformant with this also, so you can use the regular NPM tooling to work with your FHIR packages. There's a few things to say about packages. First of them is that packages are permanent. So once you publish them, at least to the FHIR registry, they will always stay there. And you cannot delete them, but the only thing you can do is basically unlist them. So that is just a sign to other people, okay, please don't use this package anymore, but it will be there. Why is this? Because basically these are building blocks, and other people will start building houses on those building blocks. And we should not be allowed to pull bricks out of someone else's house there because they're building something on top of it. So you can recommend to them, hey, I have a newer package, preferably use that one. I'll give you the versioning strategy later, but they will remain there as is. And secondly, packages. I'll give you the minimum requirements of what a package is, but packages are also being used to distribute implementation guides and to build other implementation guides on top. And we'll see a bit more about that in our next slide, where we'll be talking about the package manifest. So this is that package.json file, the first thing that came out of the box. And on the left, I showed you a representation of the JSON file, and we'll just quickly walk through the most important parts in here. You can all read this on the Confluence page. We'll share the slides. We'll share the link to that. There's only a few things mandatory in there. You need to have a name for the package, and I'll go deeper into naming strategies. You need to have a version for the package. I'll go deeper in that one too. You need to have a description. We need to know, at least be able to show in the package registry what it is about. And we need to have an author, someone who is owning this package. And then there's other things that are strongly recommended, like FHIR versions. This is technically an array where you can specify multiple FHIR versions. I would strongly recommend you to only have one FHIR version per package version. But technically it's possible to have multiple in there. And then you can specify other packages that you depend on. You can specify some keywords that's more for searching, which we'll also encounter later. You can give a license so we can show that too. So only these four are mandatory to have a valid FHIR package. But then if you're making implementation guide packages, which basically means I want to make a package that other people can build other implementation guides on top with the IG publisher, then there are some more mandatory parameters in there. And you need to make sure that they stay in sync with what's in your IG resource. So many of these values you'll see here, like the title and the canonical, etc., they will be synced, and the maintainers, they will be synced with your IG resource values. And IG publisher also does this for you. So that's the package manifest. Maybe we can do a quick check if there's any burning questions here, Ardon.
It's Marco here, but
Hey, Marco.
Hi. We have no questions at the moment, so everything is super clear. I had already some
Perfect.
questions in mind for you, but you already answered that during the session, so I think we can continue. I will encourage people to, if you have a question, just put them in the tab on the session Q&A. So continue, Ward.
Thanks so much, Marcus. Thanks so much. So we've covered why we're doing this. We've covered what we are doing, and now the question is, how can I use this marvelous FHIR tool? So we'll start by using packages. How can I find the right package to build on top of? How can I install that thing to use it either on my local machine to build stuff on top or on my FHIR server? And then how can I start building my own profiles on top if I make derived profiles? Finding packages. Well, currently there's a few strategies to do that. One way to do it is you go to the registry.phir.org/guides. There's this nice curated overview of different implementation guides in there. You can go there and then find, for example, US Core here. And when we look at the US Core implementation guide, we look at the footer and we see, hey, the name is hl7.phir.us.core, and this is the latest version number. And also when you go to the published versions here, version history, you will see the other versions that will be available from this IG and also of this package. That's the happy flow. But then again, there's many ways where you still have to find right now on Google, and not everything will be in there. There's also implementation guides, for example, that are, I think this one is actually listed here in implementation guide registry, but there will be others. You go to the rightful page that describes their implementation guide, that describes their package, and then you find those. So this is currently the situation, but with the FHIR package spec, we're also trying to make sure that we have one central registry where people can find all the right packages. And that is the FHIR package server. And this package server is an intimidating slide, but let's start on the left. So there's different people who are offering packages to the world. Of course, there's HL7. HL7 International has their own publications. For example, the FHIR core spec. It's being distributed as a package. As Graham mentioned, in Amsterdam, there's currently multiple ways of distributing all those resources. Everything will be packages. So you can find the FHIR core for R4, for example, in hl7.phir.core.r4, etc. So this will be offered from the HL7 org. This is a package feed, and it's basically like an XML, an RSS feed. So if you're familiar with reading a blog via an RSS reader, you're familiar with the format here. And so there are currently 5 different of these available. There's terminologies that HL7 shares. FHIR has some other published via the FHIR Foundation. HL7 Australia has their own. Probably not accidental that Graham lives there. And then there's the Simplifier platform. As I mentioned, this is one of the tools that I'm responsible for. This is a FHIR collaboration platform. And we also have a lot of packages being published from there. So these are all different FHIR feeds, FHIR package feeds, and they all come together in the FHIR package registry. So Simplifier is reading all those different feeds and is caching them, and is making sure that you can have a user interface on top of that you can search. So if you go to packages.simplifier.net, you will, if you do this in a browser, will be directed to the user interface where you can search for any package, but you can also go to the docs here and search in a more API-friendly way. So with your tool, search for the right package and their dependencies, etc., to get them together. This is what's currently there. Packages.simplifier.net also runs as packages.phir.org. You will find the exact same results at this moment. But what we're building, paid for by HL7, we're building a new version of registry.phir.org. So currently registry.phir.org has a search functionality already for different FHIR resources, but based on this new package registry, we'll have all the latest published content out there, and we'll provide you with a very nice elastic base search interface for all the latest FHIR content in there. So this is something coming out probably later this year. So keep your eyes on that. But you can go right now to packages.fhir.org or packages.simplifier.net and have your tool search for the right package or search for it yourself in the user interface. So then you've found the package that you're interested in. But then the question is, okay, how can I build on top of this? How can I proceed from here? The first thing that you would do if you want to use it locally is to install this package on your machine. And I should mention, you can do this separately, installing this on your machine, but you can also, it's also included in many of the popular profiling tools out there. So Forge or the IG Publisher, etc. They will all look at the packages registry to download the packages for you. And I'll come back to that in the next slide. But what you can see here, I'm using Torinox, our .NET FHIR tool, which is cross-platform, and you can just in the command line type, okay, FHIR 4, this is the R4 version, install this specific package. And what you see here is that it will install that package, but it's also looking, oh, hey, there is a package which this is based on, let me download that one and install it, etc. There's another one that's based on US Core again, it will download that. So this would be a lot of manual labor if you would do this by yourself. And now we can all automate this with machines, this entire dependency stack of packages that you're building on. So that's cool. You have a package on your machine, but you actually also want to test this in your FHIR server, or you want to make sure that you run the national packages in your FHIR server. So for this, direct support for many of the popular FHIR servers like Happy or the .NET-based Vonk is coming later this year, or later at least. People are working on that right now. But what you can do right now is just make sure that you download those packages locally, for example, with something like Torinox, and then unpack it, get the resources, and send them all to the administration endpoint of your FHIR server. And my colleague, Alexander Zoutke, wrote this nice bash script to help you do that and wraps around Torinox and get them into the FHIR server. So this is installing the package, but as I said, many people who will be building their own profiles on top of other profiles. For example, here in the Netherlands, we have the national profiles published by NICTIS. If I'm a hospital, I might want to make my own profiles based on top of that. And I think many of you will be implementers doing this. So then you want to make sure that you have all the resources that you want to build on, and those are distributed in packages. So if you're, for example, using Forge, the user interface for profiling with FHIR, you can now directly in the Forge user interface search the FHIR package registry. For example, in this case, I'm searching for US Core. I can directly search for that. I click Add, and it's being downloaded by Forge. It's being installed on my machine, and it will also crawl all the dependencies of those packages again and get those together. So then you have all the dependencies that you need to build your own profiles on top. Similarly, if you're using the very popular FHIR shorthand, all you need to do, they have this beautiful config.yaml right now, where you can specify your dependencies. You can just specify, okay, I'm building on top of HL7 FHIR US Core, this specific version, and then Sushi will download the packages for you. And all these different tools are using on your machine the same package cache. And this package cache is nothing more than a hidden folder in your personal profile folder where packages are being cached. And they're all using this in the same way. So if you download it with one, you don't have to download it again with another. And since packages are always the same, that they don't need to be deleted, that you can just keep reusing them. You don't need to update this specific version of this specific package anymore. And simply, in the same way, the IG Publisher, if you specify in your implementation guide resource, depending on this specific package, it will find that package and help you to build on top of that. So that's how can I use currently existing packages from outside to build on top of that and to start working towards making my own packages. So now we have some localized packages for my country, for my hospital, and I want to start delivering my own packages, because also my customers expect a stable version of FHIR resources to build on top of. So that consists of two steps. First, you need to package this set of resources. You need to make this tarball exactly according to specification. And then probably, maybe you want to keep it internal. I'll discuss that too. But probably you want to make this available in the FHIR package registry so other people can build on top of that and can find it in their own tools of choice. And once we start building that package, we should talk about, okay, how am I going to name things? So one of the things you need to have for your package is that name, as we discussed in this package manifest. And that name generally, as you can see, consists of letters and numbers and a few dots in between. You need to have at least one dot. That's point number 4 here. But probably, if you're familiar with software namespaces, you'll generally start from something generic, working down to more specific. And in there, you will want to specify, okay, for what region is this package relevant? Who is making this package? Number 2, the author or the organization. And 3, a bit of what it is about. So for example, when we're looking at the first one here, HL7.FHIR, well, that's clear who we're talking about. That's the organization. And they're releasing the core specification for FHIR for R4. So this is the topic here. Similarly, there's all these HL7 FHIR working groups who are, and accelerators who are publishing their own sets of packages. And they're all publishing in this HL7 FHIR namespace. And for example, there's one for the US, and these are the core resources for the US. And there is the UV. You might be wondering what that is, what country that is, but it's meant to be universal. And this is the structured data capture. So the profiles that are available for your questionnaires, etc. The UK is releasing their own core R4 profiles. Germany is releasing their own basisprofil core profiles for R4, etc. Can I also call something my own HL7.FHIR test something? No, we have a few reserved namespaces, and this is basically delegated on a feed basis. So HL7 Australia has claimed the HL7.FHIR.Australia namespace, and they can publish anything in there. Graham with the FHIR Foundation has claimed the FHIR namespace, etc. So there's a few of these that you can't go in to, but that I think is very logical, and mostly you can choose this name like in the way you want. Okay, then we have the name down, but we should start somewhere with a version. And you've seen this versioning. It always consists of at least these 3 numbers with dots in between. And these 3 numbers, they represent the major, minor, and patch version of your package. And this comes from the semantic versioning standard. We didn't invent this ourselves. NPM is using this. Many other software tools are using this. You can look at samvar.org to see the specification. And this is a clear way to specify whether I should update to the new package or not. And I'll walk you through this a bit here in this time, how a typical project might do that. But there's major, minor, version, and patch. And then one thing I should explain, if you put a dash behind that, then you can type anything here you want. So preview 1 or alpha or release candidate 1, etc. That will indicate that this is not a stable package that you should build on, but it is something that people are releasing for you to evaluate. So let's see how this would work for a software project, for a development project of FHIR profiles. So you've been working internally, maybe getting some outside feedback, and you've been developing the profiles. They look good, and everyone together, you decided, okay, it's time for a 1.0 release, the first public release to the outside world. So you'll see that 1.0 people technically, it generally expect that this is, okay, this is the first version that I basically can use in production. And since it has no annotation behind it, no label, this is a stable version that people build on. So you're giving the expectation, guys, I'm not going to change this generally, and I will continue to support this in the long run. So this is a major release, 1.0 version of the package is released. But at some point you'll find some typos in there and people are reporting issues with that. So you want to make new releases of this package. But you should of course be careful, because if you keep changing your profiles, no one is going to implement this in a hospital. So you have given them some expectation that this is supported in the long run. So you should be able to make fixes, but generally you want to make backwards compatible fixes whenever possible. So if you're just fixing, for example, in this case, I'm putting some better descriptions in there, adding some optional elements in there, that's all backwards compatible. No one's current instance of profiles generally will break from this. So this is what we call a patch release. And you see that we've updated the patch version number here to indicate that. So this is a 1.0.1 release. And if we're happy with this one, we can indicate to others, as I mentioned, we cannot delete the other one. We cannot stop people from using it because maybe they've just implemented this in their entire hospital. But we can unlist it to at least indicate, okay, we recommend that you would upgrade. And then, so this is the 1.0 version. At some point, we see that there are some major issues with, for example, the patient profile in there. And we want to make major changes. And this is the point, if we make major changes that are incompatible with the previous one, so people, if they would just update to this package, their stuff would break, this is when we need to update the major version. So this is when you start releasing a 2.0 something. And if you don't think it's ready for prime time yet, but you do want to make a package release for others to consider, then you could use this label and say, okay, this is release candidate 1, give your feedback. We have done major changes, let me know how it is. And at some point you had enough feedback, people are happy, you made some other changes, and then you can start releasing that full 2.0 version. Again, you're giving people the expectation that this will be supported in the long run, and we can enlist the other package, to be clear about that. One more suggestion, okay, there's one other minor version. When do I use that? Well, this is really for if you're adding substantial new functionality to your profiles, but it's still backwards compatible. So stuff will not break, but maybe we're introducing a new profile or a new extension that people can use. That's when you would upgrade that minor version. So in this case, we've released 2.1 and we've enlisted 2.0 to encourage people to upgrade. But maybe we can even backport this to the 1.0 branch. People are still working on this and maybe they need this and are not able to upgrade yet. Maybe it's in the law that they need to continue to support it. So you could also backport this and enlist the other version. And at some point you might want to tell everyone, okay, 1.0 is really 4 years ago now. You need to continue to the next version. Then you can start enlisting this package too. So I hope this gives a bit of indication of how you could use the versioning strategy in that. So now we should actually start, we know what we're going to create. Now we should start creating packages. There's a few ways you can do this. You can go to simplifier.net where you can create packages. Simplifier is like a GitHub for FHIR projects. So here you can work on your profiles, and at some point you're happy and you click the create new package version. It will walk you through all the steps, all the things you need to fill in the package manifest. When you click save, this package is not only created, but it's also directly published in the FHIR registry, so anyone else can find it. And that's a slide I'll come back to in a moment. And then similarly, you can do this on the command line. For example, if you're using the IG publisher, every time you run the IG publisher on your IG, it will create for you a package. So here I created run the Gen 1's version. And you'll see it almost ends with, okay, installing the package that I've just created, the dev version of that to your package cache. It's even installed on my machine already, so I can use it with other tools, which is super nice. And similarly, you can use Torinox, that command line tool I mentioned before, to package up a folder on my machine as a FHIR package. So it will create a package manifest for you, and it will put everything in JSON in the right folders, etc. So now I've created my package and I want other people to use it. And that's publishing to that FHIR package server. We've discussed how the package server looks like, and there's currently these 5 different package feeds. You need to end up currently in one of them. to be published, or you need to create your own feed. So how do I get into the HL7 feeds? Well, if you're working with your working group on an HL7 package in the IG builder, and you're going to balloting, and at some point this package has been approved, then Graham will make sure that this ends up in those HL7 package feeds, and it will be available next, picked up by Simplifier, picked up by the package registry, and be available to everyone. If you go to Simplifier, you work on your project, you create your package, it's being published to everyone via the Simplifier feed and in the package registry. And as I mentioned, you can go full DIY, create your own RSS feed, do a pull request on the file that that maintains the currently five RSS feeds, and put it in there. And of course, we expect you to maintain it and follow certain specs to do that. That's if you want to make it publicly available. If you're a big tech company that's developing their own internal standards, you might want to set up your own NPM server. As I mentioned, we're compatible with the NPM spec, so this is where you can release your own packages internally for others. Okay, I see there's not much time left, but very good. We're getting to the homework assignment here. Ardon, do you want to introduce to the people how people can get going with packages?
Thanks, Ward. This is Ardon speaking, FHIR consultant at FHIR. Just a short shout out before we head to the end of the presentation and moving forward to the Q&A, if we have time for it. I would like to point you to some of the guided exercises we've created to help you to get a better understanding of FHIR packages and how useful they are. They're hosted inside of a implementation guide on Simplifier. The link is given here as well as in the Q&A session. And the exercises break down in 4 parts. In the first exercise, you will validate, you will use the scoped validation of Simplifier to validate an instance against a specific version of a package. Then the following exercise will guide you through how to build upon a package, followed by creating your own package, and lastly, you can validate against your own package. And these exercises should be doable in 30 minutes to 60 minutes max, and are for all participants or at a beginner level. So yeah, please have a look. If you get stuck or have any questions, just reach out. You can pose your questions in the Q&A session, or contact me or Ward directly through Wehova or Zulip. So let's get back to the closing words of Ward.
Yeah, thanks, Ardon. So I have the link here still here, so you feel free to copy this and go ahead. I just wanted to make sure that we brought the message home. FHIR packages allow you to be clear everywhere on your scope. What are we talking about? Where do you want me to look for the canonicals that you're actually talking about? FHIR packages are the way to build on top of a stable infrastructure with your own FHIR resources, but also give your customers stable FHIR resources to build on. And you can be exactly clear what you're referring to. So I think we're already a bit over time. I'm not sure when they're cutting us off, but Marco, are there any questions left at this point?
Yeah, we have some questions, a few questions that we are going to answer also after this session, I think. Maybe you can answer one question in particular. Is there a practical scenario or package that you already widely used? Is it already used in the world like this?
Yeah, that's a great question, and I think that is definitely the case. So you see that the Netherlands is very strong in already releasing packages and also having other people use them, load them into servers built on top of that. So is Germany. Germany is going very strong in building through. And also, as I mentioned, Graham is building this everywhere in the internal tooling. So if you're using FHIR Shorthand, if you're using the IG Publisher, you are already using packages, and people are, yeah, it's being installed on your machine, and so you better know how to use it. Yeah.
Okay. Well, thanks, Ward and Ardon. We will answer the question that will are still open here. I think we are we're already out of time. So.
Great, thanks, Marco. And indeed, reach out via the Q&A section, or reach out directly via sessions in the Wehova app, and I look forward to talk to you all. Thanks very much.